Tyndall Effect, also called Tyndall phenomenon, is the scattering of a beam of light by a medium containing small suspended particles. Tyndall Effect is the phenomenon in which light is scattered by the particles in a colloid. This property is also shown by some very fine suspensions. Thus, a given solution can be verified if it is a colloid or not. It is also known as Willis-Tyndall scattering. Now, let's talk about mixtures. A mixture is a combination of two or more components which may fall between the two types or classifications of mixtures: homogeneous mixtures and/or heterogeneous mixtures. A homogeneous mixture is a mixture of two or more components in which the composition is uniform all throughout. A solution has two components: the dissolving medium, which is the solvent, and the solute, which is the substance being dissolved. Many various types and forms of solutes and solvents can be used to create solutions. As you can see in the saltwater solution, the beam of light is not visible on the naked eye, but we can still see that the light can still pass through. This is because of the particle size that is less than 1 nanometer. That's why it can easily pass through the filter paper without separating, and its appearance is clear. These kinds of properties describe true solutions, which does not show the Tyndall effect. Solutions appear clear because water-soluble compounds totally dissolve in water and disappear. Following this, water retains its properties, and the solution remains clean and transparent. Since our saltwater solution has a uniform composition, it is a true solution and a prime example of a homogeneous mixture. Filtration. In terms of filtration, it works best when the solute isn't dissolved in the solvent. For instance, sand and water can be separated through filtration as both compounds do not dissolve with each other. However, salt and water would not be separated through filtration as they dissolve with each other. But there are still other types of separation techniques which can be used to separate solutes from solvents. Now let's move on to heterogeneous mixtures. A heterogeneous mixture is a type of mixture that has a non-uniform composition. There are two types of heterogeneous mixtures. These are colloids and suspensions. Colloidal solutions have large molecules or particles ranging from 1 to 100 nanometer, while suspension have large particles or aggregates that is more than 100 nanometer. This can make colloidal mixtures and suspensions appear cloudy. Colloids are dispersions of solid particles in a fluid. The particle size of the dispersed material is between 1 nanometer to 100 nanometer. This small size results in material which does not sediment under normal conditions. Constituent substances of a colloid cannot be separated by ordinary filtration, because the size of the particles in a colloid or colloidal solution is bigger than those in a true solution, but smaller than those in suspension. As you can see in the mixture of diluted milk and water, the beam of light is still visible. This is because colloidal mixtures have large enough particles to scatter the light that is coming from the light source. When filtered, like solutions, it can easily pass through the filter paper and the particles does not separate or eventually settle or sediment at the bottom of the container where it is placed. Therefore, colloids show the Tyndall effect. Last but not the least, suspensions. Suspensions have particles larger than a colloid, more than 100 nanometer. These particles are large enough to sediment under the influence of gravity. A suspension is a heterogeneous mixture in which the solid particles do not dissolve, and eventually settles out of the mixture upon standing. The particles in a suspension are far larger than those of a solution, so gravity is able to pull them down of the dispersion medium. When particles of a suspension come close together, they can form aggregates called flocculates, which will settle more rapidly. In the experiment, as observed, the light cannot pass through anymore, but we can still see the beam of light. This is because particles of suspension are large enough to scatter rays of light, and the path of the ray is visible through a suspension. Therefore, suspensions show the Tyndall effect.